In this video, we're going to be learning lesson 9.2, and this is all about reflections. A reflection is a type of transformation. And our objective is we are going to be able to identify a reflection, describe reflections of two-dimensional figures, and then we're going to graph a reflection of a two-dimensional figure. All right, let's first watch a digits clip to explain what reflections are.
A reflection or flip is a...
Speaking of reflection, does everyone see the tree outside my house there? All right, sorry. Let's go back. There we go.
A reflection or flip is a rigid motion that flips a figure over a line called the line of reflection. If a point A is on the line of reflection, then its image A' is itself. If a point B is not on the line of reflection, then B and B' are on opposite sides of the line of reflection. They are on a line perpendicular to the line of reflection and are the same distance from the line of reflection. B and B' are the same distance, 3 units, from the line of reflection, the y-axis.
Okay, so let's see here. So the key concept, well, we learned that a reflection, another word for it is it's a flip. Oops. Okay. So a reflection is also called a flip, right? Because you're flipping it over a line. And it flips a figure over a line called the line of reflection. All right, so just like with translations, the figure stays the same shape and the same size. It's just flipped, right? If you can imagine an image and it's flipped across a line of reflection. Here, let's look. It says, which transformations are reflections? All right, well, this right here to go from DEF to D prime, E prime, F prime, looks like that's a slide. That's a translation, right? We took it and we moved it. We slid it down. Here, from DEF to D prime, E prime, F prime, it does look like a reflection. We took this figure right there and we flipped it over. This is a reflection across the y-axis. And then here we have DEF and then D prime, E prime, F prime. Okay, this also looks like it was flipped, right? It started up here and it flipped down. It actually flipped over, flipped across the x-axis. Okay, so 2 of these were reflections. It's just that this one had the figure reflected across the y-axis, and this one had the figure reflected across the x-axis. All right, so let's look at example number 1. It says PQRS is a rectangle. Describe in words how to map PQRS to its image, P prime, Q prime, R prime, S prime. Then use arrow notation to show how each vertex of PQRS maps to its image. All right, so the first thing we need to do, we see that we have, this is the original figure, PQRS, and here's the image figure, the second figure with the prime notation, P prime, Q prime, R prime, S prime. And the first thing we have to figure out, well, it's being reflected, right, from here to here, and we have to figure out, well, what is my line of reflection to help me describe in words how this figure is reflected. Well, we know that we have to go from P to P prime. So what I would do first is draw a line, because you need to go from P to P prime. Q goes to Q prime. S goes to S prime. And R goes to R prime. Okay. Now, just like the video said that we watched about reflections, that point, the original point and the image point have to be the same distance from the line of reflection. They have to be the same distance away, which means essentially what we have to do is see all of these lines that take the original point to the image point. We have to cut those lines in half. So you want to think about what's halfway between all of these points. What I would do is take the two closest points to each other. Q is closest to Q prime, whereas like P is a little bit farther away from P prime. S and S prime are the farthest away from each other, right? And then we have R and R prime. Q and Q prime are the closest together, so it might be easiest to figure out what is the line of reflection between these two. So what we have to do is we have to cut the distance in half. See, Q and Q prime, here is halfway between them.
You can use arrow notation to show how each...
Sorry, guys. That was a digits video. Okay, so here we have, this is the same distance to the line of reflection because it's 1 unit away here and it's 1 unit away here. It's the same distance. Here, it's got to be the same distance from P to the line of reflection and P prime to the line of reflection. So let's see, from P to the line of reflection, it's 1, 2, 3 units away. And then from P prime to the line of reflection, it's 1, 2, 3 units away. So it works there. Let's do S and S prime. From S to the line of reflection, it is 1, 2, 3, 4, 5, 6 units away. And then S prime to the line of reflection is 1, 2, 3, 4, 5, 6 units. So it works there. Because remember, they told us that a reflection, when you map a reflection, all the points have to be the same distance. Each point and its image point have to be the same distance away from the line of reflection. So lastly, let's check R and R prime. R is how many units away from the line of reflection? It's 1, 2, 3, 4 units away from the line of reflection, which means R prime also has to be 4 units away from the line of reflection. 1, 2, 3, 4. So it works for all of them. And remember, the way that we did that is we took the two closest points and cut it in half. Right? Q was 1 unit away from the line of reflection and Q prime was. So then we just figured out that basically we have to figure out what is this line. Okay? Well, it's a vertical line, right? At the point, it's along the x-axis. So this line right here is x equals 1. This is the line x equals 1 because it goes through the x value, right? Here's the x-axis. It goes through the x value 1. So it's the line x equals 1. So my answer to describe in words how PQRS maps to its image P prime, Q prime, R prime, S prime is that P prime, Q prime, R prime, S prime is the image of PQRS after a reflection across the line x equals 1. Okay. Then they ask us to use arrow notation to show how each vertex PQRS maps to its image. So just like we did yesterday, Here's the arrow notation. Line P starts at coordinate 4, 3, and it maps to P prime, which has coordinates. This has coordinates -2, -3. I'm sorry, -2, 3. Q, the coordinates for Q are 2, 1, and they map to Q prime, which is at 0, 1. R starts at 5, -2, and it maps to R prime, which is over here at the coordinate -3, -2. Lastly, S starts here at the ordered pair 7, 0, and it goes to S prime, over here, which is at the coordinates -5, 0. Okay, now that you have finished taking all of these notes, you could try the got it and then watch the video to make sure that you got it correctly.